With the development of society and the vigorous development of clean energy, hydropower projects have become more and more key development projects in the energy field. Hydropower has a long history. Hydropower uses the drop of water to drive the turbine to rotate to realize energy conversion. In order to ensure the normal operation and maintenance of the turbine, a cut-off valve must be set at the inlet of the turbine to control the operation and cut-off of the water flow. This is the turbine inlet main valve. The inlet valve group includes upstream and downstream pipes, expansion joints, bypass valve groups, exhaust valves, As a kind of mechanical equipment, the main function of the valve is to divert, cut off and adjust. At present, the water inlet valves in practical application are mainly butterfly valves, and in recent years, ball valves are also used in working conditions. A butterfly valve is a new type of valve invented to meet the actual working conditions that the ball valve cannot meet. Once it came out, it immediately got very good applications all over the world. The butterfly valve is a kind of valve invented according to the structure principle of the ball valve, taking its advantages and avoiding its disadvantages. It has a simple structure, convenient processing, reliable sealing, and is lightweight. It can be manufactured with a large diameter. It has the advantages of convenient maintenance, and so on. Valves are used in various roles in a hydropower station: to open, close and control the bottom outlet of the dam, upstream of the turbine, to connect or shut down a supply of water, to change the direction of a supply, or to adjust pressure and flow. The most common designs are gate valves, butterfly valves, and spherical valves, the latter two designs known as quarter-turn valves. Among other considerations, the choice will be dependent on the purpose, whether to act as a flow throttle or for emergency shutoff where the near instantaneous speed of closure is assisted by one or more counterbalancing dead weights. For bottom outlets, plunger or needle valves and fixed cone valves are most commonly used. Depending on size and purpose, they can be operated manually by a hand wheel, worm or bevel gear, or by electric, pneumatic, hydraulic, or electro-hydraulic controls on demand or automatically. Casting process of hydropower valve. Using software to draw the assembly and 3D entity of valve casting. The technological parameters of the casting were determined. The middle pouring system and top riser were designed. Valve casting materials are melted at very high temperatures of 1500 degrees Celsius. After adding the standard compounds, the molten mixture is poured into the mold. After cooling, the valve blank is ground to excess details. Valve machining process. The technical specifications are fine-tuned down to the smallest detail. After completing the machining process, the next step is painting and assembly. Blue paint powder is sprayed evenly onto the surface and then heated at high temperatures. Electrostatic painting technology will produce a smooth paint layer, even color, good adhesion, and high gloss. When touched, the paint layer will be smooth and will not scratch your hands. Skilled technicians will handle the assembly work requiring precision and experience. Plunger valves are mainly used where volumetric flow rates need to be precisely apportioned or where water pressures have to be accurately controlled or reduced. Plunger valves are the correct valve to use whenever pressure heads or flow rates need to be safely and reliably reduced and controlled. Body, ductile iron. Piston, stainless steel. Piston guide rail, bronze overlay welded. Valve sealing, EPDM, bearing bush, bronze. Eye bolts for lifting, galvanized steel. Low actuating torque due to pressure balanced valve piston. Control valve in straightaway type, with customized control device depending on operating conditions. Rotationally symmetrical flow guidance. Annular flow cross-section in each position. Axial movement of the plunger by means of crank gear mechanism with self-locking worm gear unit, including position indicator. Elastic profile sealing ring located in the no-flow zone for high durability. Wear resistant, corrosion, resistant and infiltration-proof piston guides in the body by micro-finished bronze weld overlay. The automatic opening and closing mechanism is completed and tested with water.